Hello and welcome to today's webinar, How Artificial Intelligence Can Help People Be More Productive at Work. A couple of housekeeping items before we get started. You're welcome to submit questions at any time using the chat window on the right-hand side of your screen. We'll address them during the Q&A session at the end of today's webinar. If we don't manage to answer all of your questions, someone will follow up with you shortly via email. We'll also make a recording of the webcast available to you within a couple of days. It's my pleasure to introduce you to today's speaker, David Lavenda, Vice President, Product Strategy at Harmony. David is a frequent contributor to leading press outlets on the topic of information overload in organizations, which is the focus of his research. David is an international scholar for the Society for the History of Technology. David, please get us started.
Thanks, Susan, and welcome to the webinar, everybody. And glad to be talking about artificial intelligence in the workplace. Artificial intelligence, people, work, and productivity. Well, these are four terms you don't often hear mentioned in the same sentence. And what do they actually have to do with each other? And maybe even more importantly is, why should we even care? I mean, what is this all about? Well, you really should care, because according to what's going on in the press today, artificial intelligence is about to take your job. That's what you learn if you pick up any of these newspapers, and literally can't go to any of these papers without bumping into an article about how AI is either going to infinitely make life better by offloading all these jobs to machines and forever destroying society, or having no effect whatsoever. But this is certainly something that should interest people, information workers, because this is no longer a story of machines taking over menial tasks in factories or in mines and things like that nature. Now, this is talking about separating the society into an elite group of technology haves and hordes of unemployed have-nots, where their jobs are being taken over by machines. So, talking about artificial intelligence is certainly an enormous topic that's would take much longer than I have here in this short presentation. But I would like to focus on some aspects of artificial intelligence that are getting a lot of buzz in the press, and highlight those that we should be concerned about, and those which are really just a lot of noise and are not important for us in this context of information workers in business. So we're going to look at some of these aspects of artificial intelligence, and drill down a little bit into what exactly is everybody talking about, what's real, and then at the end, I'm going to show a demo of where artificial intelligence today is helping information workers make decisions, make better decisions, and be much more productive by helping present information in a way that fits more about the way they think, rather than just scattering information through apps the way we all work today. And this is a practical, real-world example that I'll be showing. But before we get into that, it's important to take a brief historical journey into where artificial intelligence got started, where some of the highs and lows have been, and where we are today, before we can examine its role in information work in the workplace. So, artificial intelligence, AI, got its start really at the Dartmouth Workshop. The Dartmouth, back in the summer of 1956, a group of leading computer scientists got together for a number of weeks and sat down and tried to mull over and consider what the future of computing would look like. And they wrote a paper that is available online. But one of the things that came out of that summer was thoughts about artificial intelligence and what computing could do to provide that intelligence. And one of the things they had was this quote from the paper that says that they looked at computing in that sense that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So what they're really talking about was a type of intelligence that would mimic the way the humans work. So almost in a way replacing the human thought process and fulfilling some of those tasks that humans do. And what came from that type of euphoria or that type of optimism was, what came a little bit later in the 60s, for those who recognize this from Lost in Space, was a kind of a typical view of what computers and robots were like in those days. And this was the idea of a very anthropomorphic view of technology, that these robots, and through the use of artificial intelligence, could pretty much mimic what people are able to do. And these machines had a very human-like form, and it remains very popular even to today, that this is kind of a vision for artificial intelligence. And there was that initial surge and initial forward advancement in artificial intelligence through the late 50s and 60s, where some of the core constructs of what we talk about today became defined. These were days when the government was funding a lot of this early work. And what ended up happening was, in the 70s, this original wave kind of hit a wall when there was a bit of disillusionment about what we were able to actually accomplish with artificial intelligence. And a lot of what happened was the realization that, first of all, these problems are much more difficult than we anticipated, and secondly, that the type of computer processing power, the database capacity we had, networking capabilities, that these types of technology problems were, the technology just was not fast enough, cheap enough, or robust enough to support the kind of computing requirements that it took to solve some of these problems. So this was kind of a dip in an age of kind of in these boom and bust years of artificial intelligence. There was a kind of a dip in activity, and then there was a resurgence in the 80s where researchers narrowed their focus. They saw that solving a generic problem was a bit difficult, and they focused on some of these expert systems. And we saw some advancements in things like optical character recognition. We saw some early advances in speech recognition. Things seem to be moving along, and then again towards the end of the 80s and into the 90s, again another disappointment, a period of disappointment with advancements and what we were able to achieve. And that's been kind of the situation until the beginning of the 2000s and the 2010s, where we've seen a second renaissance in artificial intelligence. And really the focus now is not in all of those things that were being talked about at the beginning, but we're really focusing in on two main technologies. One of them is natural language processing, and the other one is machine learning, which we'll talk about in just a moment. And the reason that these technologies have come to the fore is because of the rapid advancement in hardware processing power, high-speed networks, cheap memory, and availability of many services in the cloud. So all of these things have come together with the fact that researchers have also continued to narrow the focus and try to solve very specific problems. And this connection of faster technology, better technology, with more focused use of the artificial intelligence technology has led to some impressive results. So where does advancement in machine learning, this has driven the technology forward, and now we have tools like this one here, like this instantaneous and the advancements in how this is being applied to real-world problems, always keeping in mind and context how this affects the information worker in the digital workplace. So the kind of problems that are become the focus of AI research today are really those that look at, on one hand, analyze language in real time through natural language processing, or NLP. This ability to be able to process both spoken language and also written language and do things with that, with the language interpretation. coupled with machine learning, which is a specialized type of computer construct based on neural networks, which are really hierarchical circuits. And what's unique about them is that they can evaluate many different options quickly. So it's a machine that has many different processors running in parallel, and they can evaluate many different options or possibilities in very little time. So what these machines are able to do, when you're able to provide them with problems that have very specific rules, goals are predictable, these computers can check a lot of these alternatives. And when you couple the idea that you can either provide feedback through human intervention or through even machine intervention, these things can be quite powerful. So this is a little bit theoretical. Let's take a look in practice at where these two technologies have come to bear in recent years. And there have been some impressive artificial intelligence achievements. A couple of them have been highly publicized. For example, back in 1996, an IBM Deep Blue computer beat a chess grandmaster, and that was hailed as a huge achievement, where machine over man. And a lot of the articles that appeared at the time about the end of humanity. More recently, in 2011, another IBM computer, Watson, beat some of the Jeopardy champions on television, and that was seen as another step forward. And most recently, Google's AlphaGo computer beating a Go master in October 2015. These are all achievements and milestones for artificial intelligence, but as impressive as they are, let's take a brief look at what they have in common. So all these games, these three games, have well-defined rules. The machines, we were able to teach the machines the information they needed to know from a closed and finite set of knowledge, whether it be the rules of chess, the rules of the game Go, or all the information in Wikipedia. As large as that would be, that's certainly not a tall task for a computer to be able to analyze. And the goals, which were to win the game, each in its own way. So while the number of permutations and the number of possible options to select for every given answer might be quite large, this is exactly where artificial intelligence can be brought to bear to solve the problem. And we've seen each of these three cases, it quite successfully was able to achieve more than what the individuals, even the experts in their own field, were able to achieve. On the other hand, artificial intelligence has not really achieved its original vision, which was to become a replacement for man, or a generic technology that could replace people's function in a generic sense. And one of the best examples of that was the Microsoft experiment from last year, when Microsoft released briefly a chatbot, which is a communications channel where people could communicate and have conversations with a machine online. They called this their bot Tay, and people were able to sit down and have conversations, and Microsoft was using machine learning to use people's input and part of the conversation that they were sharing with Tay to make it smarter. And of course, people were able to game the system, and it only took literally only a few hours before Tay was spewing racial epithets and saying very nasty things, and Microsoft had to take the chatbot offline. And it's been widely recognized that this type of technology is not ready for prime time. We don't know how to solve very generic problems where we don't know exactly what the scope of the problem we're trying to solve, and that exactly was the kind of thing that Tay was about. So understanding these limitations, the goals of artificial intelligence have evolved. Initially, we were looking at emulating humanity, and this has turned into be a really difficult problem to solve. So researchers have started to focus on more modest goals, such as things like you see on the right here, assisting or replacing humans for dedicated applications like surgery, or things like even autonomous vehicles where the rules are quite well defined, or all types of robots in manufacturing environments. So limiting the scope of the application make it very possible to overcome some of the biggest impediments to solving problems, and where humans are quite good at it, but machines suffer quite a bit. So just in summary, what we understand today and with today's current technology is that artificial intelligence is effective when three conditions are met. One is when we know all the relevant data that we need to consider. So if it's a game of chess, it's a manufacturing application, or it's even an autonomous vehicle, we know what the roads look like. We have all that information. Secondly, the rules are clear. So if it's a game that we know the rules. If it's a driving, we know the rules. If it's a manufacturing machine, we know what the machine is trying to accomplish. And the desired outcome is predictable. So we're all working towards a common goal, and that goal is something that we can articulate in a high level of detail. Now, these types of problems are appropriate for things like manufacturing. They're appropriate for game playing, and so on. But if you think about the information type problems that we have at work, if I'm dealing with a sales situation, I come to work and I'm trying to figure out how to move my deal forward with a prospect. I have quite a large number of inputs. I have my apps. I may need to consult with a colleague. There are a lot of places where I could go to get information that would help me move the deal forward. Secondly, what is it that I'm exactly trying to achieve? Well, I know I'm trying to close business, but there are trade-offs. Maybe I want to offer a smaller deal to get to deepen the relationship with the customer. There are a lot of considerations that I can't necessarily define up front. So it's quite difficult to be able to define these types of problems in a machine and say, okay, this is something that I can hand off to a machine. And we'll come back to this and see where this type of artificial intelligence can be used to help people make better decisions by leaving the control in the hands of the human, but using the capabilities of the machines to be able to provide better data for decisions. So where are we seeing this full automation and replacement of people with machines? Well, here's a kind of a simple example that's readily available. It's a pizza ordering bot. Domino's has one like the one we see here. Pizza Hut has one. They're built on frameworks that are provided by companies like Microsoft. Facebook has a framework like this. And what these tools do is they allow people to have quote-unquote conversations with a machine online in order to be able to order pizzas. And this is exactly the type of problem that was defined before, which is all the information is known, the rules are clear, and the goals are well defined. So we know what size, there's all sorts of things that the bot needs to get. The pizza size, what type of toppings, where do you want to deliver it, when is it going to be delivered, how are you going to pay for it. It's a very limited set of data and options. The rules about what goes with what, also very clearly defined, and what type of toppings can go with what size, and matching the price and so on. And the goal, which is to get people to buy it and get actually the payment processed and the pizzas delivered. So this is a perfect example that a machine can absolutely replace a human, whether it's somebody on the phone or through a web form. It can be replaced quite easily and give the human, the customer, the feeling that they're working together with a human, even though it's really a machine behind the scenes. On the other hand, when we go to the workplace, we don't have a lot of situations for information workers where they're doing things like pizza ordering bots. Now, in this situation, we've got a lot of unknowns. We work with a lot of apps, and people work with a lot of different apps. Each individual may be signing up for some other stuff. And what exactly our goals are and what the rules of engagement are also some things that are flexible and not necessarily well defined up front. So let's take a look at an example of where artificial intelligence can help us in this work scenario by looking at a real world product, which I'll be demoing in just a moment. But just before we get to the demonstration, I would like to just describe the environment and why this is such a hard problem to solve. So today, with the advent of the business cloud, individuals and team leaders can pretty much sign up for whatever cloud service they're interested in. The company may have dictated or provisioned a CRM system, but I say, for my team, I'd rather use a different CRM system. Well, with a credit card, I can just go online and sign up my team, and we're often using a different product. I want to use a different project management software, document management software. I have a lot of leeway into what I can use as an individual or as a team, as a department. And when you multiply that out across a large organization, what you find is that there are literally hundreds of different apps in use across the organization. So trying to make sense of all this information in any given business situation and tying and aggregating all that information in a way that makes it easy for people to process is quite difficult. So if I want to use artificial intelligence to try and piece this all together, I don't necessarily know where all the information is coming from or what potentially could be the set of data that I need to consider. So this is a huge problem. On the other hand, because the information is in a digital form, it does lend itself to being able to be analyzed and manipulated through natural language processing. And if I can somehow take human input as people are working with their apps and see what they're doing, I can use machine learning to now interpret and improve the user experience. So let's take a look, a real life example at how this works in a product. And that product, I'm going to switch over to the screen here. This product is called Harmony Collage, and that's exactly what we see in front of us. So what you see here is my Outlook screen, and I'm sure you're all familiar with that. And on the right side of the screen, you'll see that there's a Harmony sidebar. This is our traditional sidebar that we've had for many years, and what you'll notice is that there now is a new tab that says Collage. And on the Collage window, you'll see a bunch of different symbols and text. So let's take a look at how this works. I'm going to highlight an email message that I received from a colleague, and what you'll see here is that Collage is now thinking, and what it does is it is able to pull out some information. So the focus here is I'm looking at this email that I've received, and this email is talking about a customer of ours, which is Swiss Re, a reinsurance company. Collage has used natural language processing to be able to extract that topic that I'm talking about the customer in the email out of the email and look at that as a topic that I'm interested in. So it's able to look at both structured data in the sense of things like to, from, subject line, and the metadata, as well as processing the actual unstructured data that's in the text. And it pulled out two topics that it identified in this email. And what it does with those topics is it'll now go out and search across all the different apps that I'm subscribed to in the cloud, identify which other notifications mention the topics that are mentioned in this email, and then highlight them on the right side of the screen. So you'll see down below, I have all these different updates about things related to either of these two, Swiss Re or the YouTube topics that were identified. And you'll notice on the right side of the screen that these come from different sources. So this one comes from Outlook. Then there's another one that comes from, it's an email message. Then there's some stuff from Office 365, and it's in SharePoint. We've got some Zendesk notifications. We've got some Salesforce notifications from a CRM system. So what I have here is a wide variety of information sources, but they're all pulled together in a single screen. So now instead of having to toggle across all these different apps looking for this information, it's all presented to me in a single screen. Now if this is a customer and I'm focused on trying to close that deal, instead of having to go now to Salesforce, Zendesk, SharePoint, other systems and try and make sense of this, it's all presented to me right here on the single screen. You'll also notice that at the top, the top part of the screen says important updates, and if I scroll down below, I get to a point where the section reads timeline. So what Harmony Collage is able to do is it's able to identify not only which updates from other systems are relevant to what I'm looking at in the context of my email message, it's also able to prioritize which ones should be displayed first. Now, how does it do this? It uses several feedback loops that are defined by machine learning. So one of the things it does is it uses the Microsoft Graph to be able to understand which of these people are closer to me. Using that affinity score that's provided by the Microsoft Graph, Harmony Collage can prioritize some of the messages based on how close these people are to me in the sense of our working together. Secondly, it also looks at the frequency that this topic appears in the different applications. It looks at how often these topics appear within applications and how many different applications it appears. It also has a time factor. So if a topic hasn't appeared in a period of time, it will time out and become less important. All these different factors are taken into account and add to the score, which lowers or raises the importance of the notification in the screen. Additionally, if I ignore a topic, and I have the ability to right-click and ignore a topic, or in some cases I can also add a topic if I think that there's one missing, I have the ability to add a topic. And if I adding and subtracting topics also provides input, feedback input, to the machine learning algorithm that shows the Harmony Collage which topics are more important to me or less important to me, and therefore raises them up to the top level. So what I end up at the end of the day is bubbling up to the top of the screen the things that matter most to me relevant to the context of what I see in my email message. And that's really important because in this age of information overload, instead of putting technology first where I have to toggle and look for the information, Harmony puts the human first, puts the human in the center by making the information available through topics, which is the way the brain works. People think in terms of customers, services, products, projects. They don't think in terms of Salesforce or SharePoint or email. And that's exactly the way the information is presented. And the information presented here is not simply just notifications that I can see. These are live notifications where I can literally click on a button here and launch the native application in context. I can see exactly that document that's being shown there. I can make changes to the document and then close up when I'm done and go right back to where I was before. So not having to navigate away and search for that information in another app, but be able to work on it directly from here. I can also share that information. So I can click on the button and then send that information to somebody with a link that will take them directly to SharePoint, which can then be opened up through the Harmony product directly without having to navigate away or deal with attachments. So that's really helpful to be able to do that. Also, you also have other types of information that can be gleaned here. So, for example, I also have access to information directly in the Microsoft Graph, so I can also discover new things about that I may not be following that might be related to topics. So if I decided that I want to follow this a topic, I can literally just click on it, and this will now be will raise up an importance in how I see the information appearing in my Harmony Collage stream of information. So this is just a short introduction to how Harmony Collage is able to use natural language processing in the sense of being able to extract the important information from email messages and assign the important topics, define those topics, and do the same for every application that I'm working with, then match those topics and show them in context of the email message. So that's the natural language processing capability. And secondly, it then uses machine learning, both in the sense of automated feedback, either through things like the Microsoft Graph or through the frequency of how often these topics appear in the different applications, or in the sense of human feedback, in the sense of how many times I click on something, or if I ignore a topic, or if I add a particular topic to my list. So these are all types of operations. Machine learning can then be used to sharpen the information that's shown to me. And what this gives me is the ability to make better decisions. So all the information is presented to me as a human. I can now make the decision of what I need to do to close business. I can launch applications. I can send emails. But this is not a process that can be fully automated. It can, however, use the artificial intelligence to allow me to be more productive and to make better decisions. And that's really a prime example of where artificial intelligence today can be used to help augment intelligence rather than replace people, certainly in the information realm. So that's that's the demo, and I would just like to summarize is that, again, in a world where you're making decisions with a lot of disconnected inputs, and we don't have a finite set of inputs predefined, and we don't know what the rules are, and we don't know what the end goal is necessarily is ahead of time, the best thing that we can do is we can use artificial intelligence to help organize information the way the brain works by topics so that the human can then make the best decision. And I don't believe that anytime soon these processes are going to be replaced, because the problem is not one of computing power, it's one of the rules aren't clear and the goals are hard to express. And that's why topic computing is the way of the future, and it's available today from Harmony. So this is something that's available, and you can try it out yourself, and we'll give you some instructions about how you can try it out, and be in touch with us to get even more information about how this works and how this can provide a value and productivity for you in your own digital workplace. So with that, I'm going to turn this back over to Susan and answer the questions that have come in since we started and end out the webinar.
Thank you, David. As David pointed out, if any of you would like to try Harmony Collage, please answer the question that's on your screen right now. And while you are answering, I will ask some of the questions that you have been asking. Let's start with, you just talked about topic computing, artificial intelligence, and intelligence augmentation, David. Can you restate how those three concepts relate to each other, and what does that mean for the information worker?
Yeah, thanks for that. Okay, so we looked at artificial intelligence about using primarily natural language processing and machine learning to solve problems. And we came to the conclusion that these technologies can help people make decisions, but they can't really help automate the information workers' decision-making process today. The best we can do is we can use the technologies to automatically extract topics, which is what we call topic computing. And those topics are organized the way the brain works so that people can focus on their work without having to have use the cognitively taxing effort of toggling between different applications, searching for information, or things like the names of projects and products and services may have different names in different applications, and that's very difficult to try and piece together. So the combination of topic computing using artificial intelligence leads to intelligence augmentation. So what we do is we empower the human by putting the human at the center to be able to make better decisions in the workplace by providing the information in the most efficient manner and then allowing people to take action in native apps without losing context, without losing where they are in what they're trying to accomplish during the day.
Thank you. The next question I see is, in the demo, you showed that you can launch the native apps in context. Does that work for all apps or just for a select few?
Yeah, thanks. So I'm going to switch back to the interface here. So the philosophy of Harmony Collage is to support any app that people use. Because I said before, today it's impossible in any organization to define exactly what cloud services people are using when they can sign up for their own cloud services using a credit card. Having said that, today we do support these systems, SharePoint, Outlook, Dynamics 365, Salesforce, Yammer, Zendesk, as well as IBM Connections. And we will be adding additional systems over time. We're working on one now for Slack, and there's a roadmap of additional connections. Over time, we also foresee having an API. The plan is to have an API to allow end users to create their own connections and not have to be dependent on Harmony to add those systems. So we can realize that vision of allowing anybody to use any of their current systems and get this value of topic computing with whatever products they're already using.
Very nice. The next question is, I'm using Harmony today, but I don't see the Collage tab in my Harmony sidebar. Is it a separate product that I need to purchase separately? And if so, how much is it?
Right, good question. So if you're as I mentioned at the beginning, the Harmony sidebar is something which has been available for quite a long time. This is the traditional view that most people are familiar with. We have added the Collage component as a tab in the existing product. So if you're an enterprise customer or you're a user of Harmony and you're up to date with the latest version, this is available in what you already have. You simply go to Options in the Harmony screen, and under People, you have the ability to enable Collage, and that will then appear in your own workspace. So if you want to give this a try with what you've got, you can connect to that yourself, or you can sign up for the enterprise evaluation and have that have the availability to see it through that.
Thank you. The next is, I'm not sure I understand where the topics in the demo you showed come from. Do I need to populate the topics ahead of time?
This is one of those questions that really gets to the heart of the difficulty of understanding enterprise information when it's spread across many systems, and the immense value that Harmony Collage brings to the users. So in many taxonomy projects, when you're trying to understand what the scope of information in your organization is about, you either have to work kind of top-down, where you start with a taxonomy project, which almost always fails because people have difficulty agreeing on what those terms that are important are, or you allow people pretty much to use whatever they want, in which case it becomes very difficult to have a common language because everybody's using a different set of terms. Topic computing, on the other hand, builds the topics automatically from the data itself. So it literally uses the natural language processing to identify those proper nouns which are interesting, which then can be identified as topics and stored in the system. Of course, you have the ability to ignore things that Collage thinks are topics, or you can add additional topics, but the system is fully automated. So if you think about it, at the end of the day, with Harmony Collage, what you end up getting is a de facto taxonomy of what terms are being used in the organization, matched across the different systems. So, some of the things that this enables people to do is to understand which topics are trending in different locations, which topics are trending in different geographies. Do some analytics on topics, allowing you to understand what people are working on in the organization and what things are most important. So this really, for the first time, allows people and organizations to get a grip on what is really most important in the company without having to do some back-end integration or require people to predefine the terms ahead of time in order to be able to analyze them. So this is really quite powerful in the sense that this topic computing brings more than just the ability to see things in a single screen. It also enables and empowers organizations to really understand how their organization is working directly from the data that's natively flowing.
And one last question. How do I try out the topic-related features you showed?
Yeah, so what you can do is you can either download the free product, or you can sign up for the IT eval that Susan mentioned by filling out, just clicking on the poll question. And we'll be happy to, for qualified companies and individuals, happy to provide you with that. And we look forward to you taking advantage of that and getting your feedback and input on your experience with the product. And we invite you to do that today.
Thank you, David, for that great presentation. And I'd like to thank everyone again for joining us today. As I said, you'll receive an email with a link to view the webinar within a couple of days, and if we didn't answer your question, we will get in touch with you. And we look forward to meeting you again at our next webinar.